So let's go back to our spring. So let's start at some position. We'll call it x equals 0. We're going to pull it back to some maximum displacement. We'll call it x max. And actually this has a name. What do we call x max? Amplitude. Okay, so we're going to pull it back here. Alright, so when I let go of this, what happens? It goes to the left. And why does it go to the left? Because there's a force acting on it, right? The spring force is acting on it. And so at this point, there's a force now acting this way, force of the spring, and this actually would be at a maximum value. It's now pulling on the spring in this direction, right? So it's going to start accelerating it this way. So there would also be an acceleration, F equals ma, in this direction as well. It's going to start accelerating it in this direction. Now, as it's moving, what's happening to the force? It's actually decreasing. So the force itself is decreasing as it's moving this way, as is the acceleration. But what's happening to the velocity? It's increasing. So even though acceleration and force are going down, it's still getting, there still is an acceleration, so it's still getting faster. So it's going to start speeding up in this direction, this way. Okay? So we could say, all right, that's an A max. This would be a velocity of 0 at that point. Right? We just pulled it back. It stopped. We let it go. It's going to start speeding up in this direction, accelerating this way. Right? Okay, so it's going to keep getting faster and faster and faster. Now when it's at its equilibrium point, well, what's true about the force at the equilibrium point? It's 0, right? So it's no longer stretched or compressed at this point. So we'd say the force here is equal to 0. Therefore, what's the acceleration? Also 0. So there's no push or pull at this point. So the force and acceleration will both be 0. Now, does that mean that it stopped? No. In fact, it's actually reached its maximum velocity because it's getting faster, faster, faster. When it reaches this point, it now has a max velocity right there at the equilibrium point. Okay? Now, it doesn't stop. It keeps moving. It keeps moving because it has a velocity, it has an inertia. It's going to keep moving. However, as soon as it starts compressing the spring, what happens to it? Starts to slow down. So there's now going to be a force going this way, right? Slowing it down. There's an acceleration going this way. There's an F and an A both slowing it down. So this is going to continue to move this direction. It's going to be slowing down, 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 down until it reaches some point over here, okay, where the spring's now deeply compressed. It's going to keep slowing down until it reaches that point. Now, if there's no friction, what should be true about this distance? Should be the same as this. So this x max over here should be the same. This would also be the amplitude. Okay? It has stopped at this point. So we'll say, all right, v is 0 over here. What should be true about the a and the f over here? It's maxed out. So remember, f equals kx, regardless of whether you pull or you push, it's still the same distance. It's still going to push with the same force. So this would be an F max. This would be an A max. All right, what happens now? Well, now it's going to push it back, right? And so this is the identical except in the opposite directions. This is now going to be pushing back. It's going to accelerate it in this direction. It's going to get faster, faster. It's going to reach its maximum velocity here. Now it's going to start stretching the spring. So the spring's going to now push back in this direction. It's going to slow down, 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 down. It's going to stop over here. And then what? Then it repeats the cycle. Okay? So the time it took to go from here and back, we call that one cycle, or the time, we'd call it the period that it takes for one cycle. So that's what it would be from here to here. And it's going to repeat. So this is called a harmonic motion. Okay? It's repetitive. It it's continuous, it's going to go back and forth. You know, if there's no energy loss, it would just do this forever and ever, right? And it's simple. I mean, it doesn't maybe sound that simple, but relative to other possibilities, this is a simple case. It's just going to go back and forth and back and forth. Let's look at the energy, what's going on with the energy. When I pull it back here, what kind of energy have I now given to it? Spring potential. It now has some spring potential at this point. Would you consider this a max or a min spring potential? A maximum. So it has its maximum at the amplitude point, at the maximum x. Right? And how much kinetic does it have right here? 0. Okay? And it's going to, now once I let go, it's going to start moving this way. As it starts moving this way, what's happening to its potential energy? It's decreasing, right? It's losing potential. Where's it going? Into kinetic. It's losing potential, it's gaining kinetic. Until it reaches this point, all of the kinetic, all of the potential turns into all the kinetic. So if I had 5 joules to start with here, I must have 5 joules at this point. Okay? And my US would therefore be what? 0. And the same thing happens here. It's going to start compressing. It's going to start storing energy. My US is going to be a max over here, and my KE is 0, and so forth. Okay? And then this would just repeat itself back and forth, back and forth. All right, so that's the basic concept for the